Okay, our last lesson in this unit is going to be on distinguishing special quadrilaterals. Note that we're not worried about proving so much special quadrilaterals. We're not going to use all those properties to prove kites or rhombuses or rectangles, but we do want to focus on a particular kind of problem, specifically called kind of a coordinate proof. And then we're also going to just look at using those properties that we know to kind of narrow down and define which special quadrilateral it is. Okay, so we're not going to be, again, focused on two-column proof so much in this, but focusing on two types of problems. One, these coordinate proofs, and then secondly, just sort of using those properties to narrow down which specific one we're talking about. All right, so we're going to focus on the coordinate proofs first, and you see that we've got it kind of narrowed down to 5 steps for you. So coordinate, meaning they're going to give you kind of these points here. So first one is just to draw a rough sketch, and that doesn't mean, to put tick marks on everything and totally sketch it out. -3, -7. So I would do something like this. -3, -7, I would say is down there. I do encourage you to label the points. It's much easier if you see them on your diagram. B, -9, 1. So I'd say -9, 1. Let's put that out here. B, -9, 1. C is 3, 9. So I'd put that maybe up here somewhere. I'll call it C, 3, 9. And 9, 1 would be out here somewhere maybe. Let's call that D, 9, 1. So again, it doesn't have to be perfect, just kind of to see where those points are and label them. It'll be much easier to work with. All right, so notice what we're going to do first. We're starting at the top of that graphic organizer. We want to see if it's a parallelogram. We know that means opposite sides parallel. We are going to be using slope to do this. We're going to be using slope for all of this. If you've forgotten how to calculate the slope of a line, you subtract the y's on top, you subtract the x's on the bottom. That'll tell you the slope. We know if it's parallel, that means slopes are the same. We know if it's perpendicular, that means slopes are opposite reciprocals, in case you've forgotten that from your algebra days. Okay? So first thing we're checking for to see whether opposite sides are parallel. So look at the slopes I'm looking at. I'm first looking at AB right here and CD, and I want to know if those have the same slope, because then they'd be parallel. So the slope of AB, that's here. I'm going to do y minus y, so 1 minus -7 over -9 minus -3. Make sure you keep your points going in the same order for x's and y's. That's what's going to be 8 over -6, which is -4/3. So if I do that for CD, I would do 9 minus 1, y minus y over 3 minus 9. That's 8 over -6, which again is -4/3. So that implies that AB and CD are parallel. But that's just one pair of sides. So I know this. I can mark that on my diagram. Now I'm going to check BC and AD. All right, so first I'm doing AD, that's here on the bottom. Let's do y minus y, so -7 minus 1 over x minus x. So that would be -3 minus 9. So that's going to be -8 over -12. Two negatives make a positive, and that reduces to 2/3. I'm going to do BC, so that's going to be 1 minus 9 for the y's, -9 minus 3. It's really easy to make computational mistakes, so make sure you're careful. Otherwise, that will mess up your slopes, and you won't know that here again they are the same, so they are parallel. So is it a parallelogram? Check. It is. All right. Now, if it's a rectangle, we know rectangles have right angles. So right angles come from perpendicular. Remember, if there is one right angle, there's all right angles. So I really only need to check one perpendicular. Well, I've already calculated these slopes. I'm going to look right here. All right. I'm looking at the slope of AB. I can look up here. That was -4/3. Right? And then I can look at the slope of BC. That was 2/3. Those are not opposite reciprocals, so they're not, perpendicular. So this would be no, there are no right angles, so it's not a rectangle. All right, now we need to check to see if it is a rhombus. In a rhombus, the diagonals are perpendicular. All right, so now I haven't calculated those slopes yet. So I'm going to look at the slope of, what did they do first here? AC. So let's look at the slope of this diagonal right here first. All right, using my slope formula, AC, that would be 9 minus negative 7 over 3 minus negative 3. Whoops, minus negative 3. 9 minus negative 7 is 16 over 6, which reduces to 8/3. Right? Now I have to do the slope of BD. So that would be this guy up here. All right, so now that we give you space to calculate it, so that would be 1 minus 1 over 9 minus negative 9. That's 0 over 18, or 0. If they're going to be perpendicular, those slopes should be opposite reciprocals. These are not opposite reciprocals, so they are not perpendicular, so it is not a rhombus. All right. Well, the only way it could possibly be a square is if it's both a rectangle and a rhombus, but we had no for rectangle and no for rhombus, so it doesn't meet either one of those criteria, so it's certainly not a square. So by process of elimination, right, all we really had was a parallelogram, and so that would be my answer. All right, so let's try another example so you can see how this works again. Again, the only calculation we're using is slope. You don't need anything else. So let's begin with kind of a rough sketch here. Let me get on the screen. I'm all over the place. All right, 0, negative 6 would be down here somewhere. Again, mark the points. As you can see when you're calculating slopes, it's much easier to see them on a diagram. Negative 4, 2. This would be B. C would be 4, 6. And D would be 8, negative 2. Again, just a rough sketch. You can see mine doesn't really look like anything based on what I drew, right? Rough sketch. All right, so first thing we're looking for, is it a parallelogram? I'm going to look for opposite sides. So I wrote down the slopes I want. I'm first looking at AB and I'm looking at CD. So I'm looking at these two. So AB, 2 minus negative 6. Remember, it's y minus y over x minus x. So that's 8 over negative 4, which is negative 2. Now I'm working on CD. So 6 minus negative 2 over 4 minus 8. That's 8 over negative 4. That's negative 2. They're parallel. That's good news. Let's mark that on my diagram. Now I'm going to look at the top and the bottom. Let's look at AD. That would be negative 2 minus negative 6 over 8 minus 0. So that's what? 4 over 8, which is 1/2. Now I'm going to do BC. So that would be 6 minus 2 over 4 minus negative 4. That's 4 over 8, which is 1/2. Oh, also good news. So indeed I have a, whoops, I'm off the screen here. Indeed I have a parallelogram, because my opposite sides are parallel, even though my diagram doesn't look anything like it. Okay? All right, now, next thing we do is check to see whether we have a rectangle, right? Remember, in a rectangle, you have to have a right angle. So I'm specifically, this time, I'm looking at AB and I'm looking at BC, so I'm looking right up here, right? If I have a right angle, these two lines should be perpendicular. And if I know they're perpendicular, I know the slopes are opposite reciprocals. So let's fill in those numbers. The slope of AB, if I look up here, was negative 2, and the slope of BC was 1/2, right? So again, this slope right here was negative 2, and this one was 1/2. That was our opposite reciprocals. So perpendicular, so I have a right angle. So yes, it is a rectangle. Because remember, if you have one right angle, you actually end up having all right angles. So you only have to prove one. So we've got a parallelogram that's now also a rectangle. Now remember, to check for a rhombus, we're going to check the diagonals. All right, so let's look at the slope of AC. Look up in your diagram. I'm going to do y minus y, so 6 minus negative 6 over 4 minus 0. That's 12 over 4, which is 3. And then I'm going to do BD, which would be 2 minus negative 2 over negative 4 minus 8. That is 4 over negative 12, which is negative 1/3. Those are also opposite reciprocals. So those diagonals are perpendicular. So yes, again, we have that it's a rhombus. So we have a parallelogram that is both a rectangle and a rhombus. So a square would have to be both of those, which yes, it is. So yes, indeed, it is a square. All right. Now, when you do these in the homework, we aren't going to set it up for you in all these steps, but you should be showing me these steps in your work. Okay, I do not want to just say, yes, it's a rectangle, yes, it's a rhombus. These are the steps we're going to want to see. I'm going to want to see the calculations of slope. I'm going to want to see the explanation as to why. What do those slopes mean? So this is the kind of work we'd want you to show. All right, so distinguishing special quadrilaterals. I like these problems. The directions say use the markings in each of the diagrams below to determine the most descriptive name for each. So yes, I know they all look like squares. That's the idea. But they're not squares, right? We want you to use the idea and the properties that we've talked about to determine what each one of these is. So if I were to write those properties out, for example, on this one, I have one pair of opposite sides parallel. That leads me to believe it's a trapezoid. So now what other possibilities do I have? If you think about that graphic organizer, the only other option I have is for it to be an isosceles trapezoid. And I have those two non-parallel sides congruent, right? So non-parallel sides congruent leads me to believe it's then an isosceles trapezoid. So that would be the answer to A, kind of talking about those properties. So here the first thing I see is that the diagonals are perpendicular. So if you look in diagonals perpendicular, if you go down that property, you will find that you might have a rhombus, you might have a square, or you might have a kite. Right? So I've narrowed it down to those three to start. I also can see that the diagonals bisect each other. So diagonals bisect each other. Well, from the three choices I have, that rules out kite, because on a kite it's only one diagonal bisects the other diagonal. So now I'm down to a rhombus or a square. Think about these markings. All four of them are congruent. So doesn't that mean if I added that this whole diagonal would be congruent to this whole diagonal? So the one that's kind of hiding is that the diagonals are congruent. Well, which one of these has congruent diagonals? It would have to be the square. So congruent diagonals rules out rhombus, and I'm left with a square. So that's how we're going to kind of use these properties. That was a trickier one. Here I have one pair of opposite sides, parallel and congruent. That should ring out right away. That's the only information I have. I hope you realize that is a parallelogram. That was one of the ways we had to prove a parallelogram. Okay, on this one, what the heck do these angles mean, right? Trace them over if you're not seeing it, right? Isn't that a Z? If alternate interior angles are congruent, doesn't that mean these sides are parallel? So I have one pair of opposite sides parallel. Right? That means I have a trapezoid because I don't know anything about these sides. I don't have any other angles. And then I have the non-parallel sides congruent. That's these. So therefore I know it's an isosceles trapezoid. Here I would say all I know is that I have both pair of opposite sides congruent. Both pairs of opposite sides congruent. That should also ring a bell from the last section, right? If both pairs of opposite sides are congruent, we have a parallelogram. I don't know anymore. I don't know anything about right angles. It's certainly not a rhombus because they're not all the same. Right? Here, these markings tell you I have one pair of opposite sides, parallel and congruent. So that leads me to believe I have a parallelogram, but then there's more information. What is this telling you right here? I have a parallelogram that has one right angle. Well, we know if a parallelogram has one right angle, it has all right angles. Therefore, this must be a rectangle. And I don't have any other markings to tell me that it would be a square or anything further. Okay, so those are really going to make you think. Keep that property sheet out in front of you as you do those.